Okay. So today we're going to cover for loops. They're very, very similar to counting while loops. And so part of the reason why we put so much effort on while loops is that it should make today's concept much easier. Some of you will have already seen for loops in other languages. The concepts are the same. Like, everyone has seen loops before. The hard thing with loops is getting the concept. Now it's just learning new syntax to see how to use a for loop. Okay, so overview today, we're going to recap counting while loops because they are almost identical to how we'll use a for loop. Then we'll see the syntax for for loop, look at examples of for loops, and then talk about variable scope at the end. Any questions on anything before we get started? Okay. So let's recap counting while loops. What are the two requirements we said are needed for a while loop?
Condition is true, false.
Yep, so condition might be true initially, has to become false at some point. Usually involves using a variable in the condition. What's the second thing?
Is it updating the variable?
Yep, we have to update the variable in some way. So with counting loops, that usually involves increasing or decreasing. With validation loops, it usually means getting new inputs from the user. So syntax, I think people mostly get syntax for while loops. Big thing, just, create your curly braces, hit enter a couple times, then write your code. Even when we do for loops, it'll be the same thing. For loops have these two curly braces. Make sure you line them up properly before you actually start coding inside. And then you don't need an else statement after the while loop because we know if code runs after this loop, we know it's because this condition is false. Otherwise, the loop would have kept running. Yep. Okay, so we'll do this one as a class because we've seen this example a few times. We want to print Morehouse 3 times. We have this int counter variable equal to 1. What is the condition if we want this loop to run 3 times?
Counter is less than or equal to 3.
Counter is less than or equal to 3. I'm starting to see people have what we call off by 1 errors, especially when we start this counter at 0. That kind of throws people off on what to do for the condition. I would encourage you to just count on your fingers. So for this example, if counter starts at 1, the loop runs the first time. Then counter becomes 2, runs a second time. Counter becomes 3, 3 is less than or equal to 3, so we run a third time. Then when counter becomes 4, we don't run again. So that's how we know this loop would run 3 times. All right, so counter is less than or equal to 3, and then we have to update counter at the end. So we're increasing it by 1. Print the even numbers from 0 to 20. So we're starting at 0, we want to print 0, 2, 4, 6, all the way up to 20. What would our condition be in this case?
Less than or equal to 20.
Yeah, so even numbers less than or equal to 20. And then what do we do for the update?
Plus 2.
Yeah, we want to increase it by 2. So the counter doesn't always have to go up by 1. It can go up by 2 based on the context. All right, final example, microwave countdown. Timer starts at 15. We want to count down to 0. I think countdown is where people are still having some troubles. Lab 7 has a countdown problem at the end. People generally are good about initializing the variable to the right amount, but then struggle with this condition. What is our condition in this case?
While time is greater than 0.
Yeah, so when you're thinking about while loops, try to think about the concept. So if our timer starts at 15 and we're counting down, we want to print out 14 and 13 and 12. Think about to what value we want to go to. We don't want to print -1. So that tells us that our boundary is going to be somewhere around the 0 mark. And then is it greater than or less than? In this case, we want to keep running while time is greater than 0. As soon as it's less than 0, we stop. So yeah, in this case, while time is greater than 0, we decrease the time each time. And then at the end, we know why do we not have to put an if statement here to check if time equals 0 to print your food is ready?
If it's less than 0, then it's going to go outside of while loop automatically.
Yeah, so at this point, we knew timer was 2, then 1, and once it equaled 0, 0 is not greater than 0. So we know at this point, time has to be 0. So we can just print out your food is ready. All right, any questions on any of these examples? Okay, so we'll pivot over to a new topic in for loops. Sorry, again, syntax, while loop syntax. You're going to note it's going to be almost identical to the next slide. So there's only 2 things that change. The first is in this for statement, we change this header. And then the second thing is Here we said we'll like change the variable inside of the while loop, whereas in for loops, we change the variable in update at the end. So we use the keyword for, FOR. You can't name a variable for because C++ recognizes that as a keyword. And there's three parts to this: initialization, condition, and update. And we've actually done all three of these things with while loops. So we'll come back to the slide, but I think it's easier to see it in direct comparison to a while loop. So this is how we wrote our code to print Morehouse 3 times. In this example, what line is our variable initialization? Yeah. So this line here is our initialization. What part is our condition? Yeah, so this counter is less than or equal to 3. That's our condition. And then what is our update? Yeah, so if we were to write this in a for loop, it would look like this. For, you put your variable initialization first, int counter equals 1. I said in 95% of cases, semicolons only come at the end of a statement, or at the end of a line. For loops are the one exception, where we put a semicolon between each of the 3 segments, but not at the very end. So you're going to have 2 semicolons total. So int counter is equal to 1. Counter is less than or equal to 3 is our condition. Counter equals counter plus 1 is our update. And then you'll note we still have the curly brace at the end, and then the closing curly brace here that's lined up with the F in for. Yeah?
Wait, so for is just a short version to write the code?
So generally we use for loops if we know exactly how many times a loop is going to run. So what we call like the counting loop. While loops are used usually just for validation problems. I taught both together with while loops because I didn't want to have so much different syntax when we first learned it. And I think with while loops, you have to explicitly write each of them separately so you really learn it. But the standard is, if you know it's going to be a counting problem, to just do it like this because it's shorter. And as we'll see, there's less rooms for mistake if you do it with a for loop. But we'll get to that later in the lecture. Okay, so the 3 parts we talked about. Note that because we learned while loop, it's like identical. The only difference is where we put the code. So in while loops, we initialize the variable outside the loop, whereas in for loops, we can do it inside, in this header. With the condition, I guess that's kind of the same. The condition goes inside the check here, and it goes inside the check here. Then the update. In the update, we always put it in the while loop. Here, it just goes at the end of this for loop header. For me personally, this slide is easier to remember for loop syntax than the previous one, just because you can see how everything maps to everything that we've learned earlier in the semester. Anyone have any questions?
So it's just compressing everything into one line. So before, you can essentially like put it for if as well, or is it just a while? Like can you compress a if statement to for?
No, this is only for loops. If statements, we still have to define the variable elsewhere, and then yeah. So that not really different statements. Yeah. So note, both of these examples, the code is going to run 3 times. We're going to print out Morehouse 3 times. So both code segments do the exact same thing. Okay, how does a for loop actually execute? The first step that's always going to happen is the initialization. So we set the counter variable equal to something. The second step, let me put up this next one. So the initialization is always going to run once for the loop. It's not that every time the loop runs, we set counter equal to 1. That only happens the first time that the loop runs. So counter is equal to 1, and then steps 2, 3, and 4 keep repeating in this order. So step 2, we're going to check the condition. So what's the value of counter right now? 1. 1, that's less than or equal to 3. the next line we run, it seems like it would be this. And this is a super key distinction. The next one that actually runs is all the code inside the loop. So we print out Morehouse, and then finally we do step 4, which is to increase counter. Can anyone guess why that update is happening after the code runs?
Because it's update.
Okay.
You gotta like actually do something before you can update.
Yeah, so
It has to be update.
some trouble that I saw people having with the Wordle project is inside their inner while loop with index, they first got the letter. They said letter is equal to guess of index. So if index was 0, they got the first letter in guess. Then they increased index by 1. And then they checked, does letter equal answer of index? And so at that point, they were checking like the 0th letter of guess versus the first position letter in answer. And that was incorrect. Which is why I typically always said, like, do your update variable at the very end of the while loop. That's like a very subtle error that can happen with while loops, and that can never happen in for loops. Because in for loops, the computer will always do the update at the very end of the loop. Does that make sense? Okay. That's part of also why I wanted to teach while loops first and have you actually update the variable in the loop so that you would notice that nuance. I think a lot of people take this for granted that it does it at the end of the loop, but you can run into some nasty errors if it doesn't do that at the end of the loop. Okay. Any questions here? Okay, let's just see it in the visualizer. We'll take that code that we wrote here. Okay. Let's run this code. Okay. So line 6, what's going to happen to the counter variable here? What is it going to be set to?
1.
Yep, because we have int counter is equal to 1. And then is that less than or equal to 3? It is. So we're going to come to line 7 next. So counter got set to 1. Note that, okay, it's kind of cut off, but we have counter plus 1. Okay. We print out Morehouse, so that's going to come here. And then what's the next thing that runs?
Counter equals counter plus 1.
Yeah. So we actually increase this first. So counter is 2. Does this int counter equal 1? Does that run again?
No.
No. This part runs again, though. Counter is less than or equal to 3. And 2 is less than or equal to 3. So we print Morehouse again. Now what's the new value of counter going to be?
2. Alright.
So it's 2 right now. Yeah, so we're going to increase it to 3. Is that less than or equal to 3? Yep, so we're going to run line 7. Print out Morehouse. What's going to be the new value of counter? 4. Is that less than or equal to 3?
No.
No, so we exit the loop. And if we had some code down here, that would run. All right. Any questions there? Okay. Yeah, so again, initialization is only going to run one time at the start of the loop. Then we just do steps 2, 3, and 4 over and over until the condition becomes false. Everyone good with that? Okay, so now I'm going to have you all write out some for loops, make sure we understand. So we're going to use the while loop example that we saw earlier in class, but you're going to write it with a for loop. So if we wanted to print all the even numbers from 0 to 20, but do it in a for loop, how do we do it? Write it out so I can see what it's looking like. Go on, Chris, let me do it. All right, have someone do the first one while the other helps, and then we will rotate. We have a few different problems. Sandra, can you come up? Or Omar, if you want to come here. Then Calvin, if you're okay joining here. Yeah.
Show us the for loops and axes.
Yeah. Syntax, again, we're trying to print out the even numbers.
Writing?
Yep, we're writing the for loop for, write a for loop to print the even numbers from 0 to 20.
Even numbers to what? Even numbers to 20. Even numbers to 12.
Printing the even numbers from 0 to 20.
Nah, the variable he uses even numbers, so I gotta use that one.
Yeah, I get that.
Even number, see out.
Even number equals 0, even number is less than equal to 20, even number, what is it, equals even number plus, or equal plus, and then see how.
Okay, I think people are on the right track. Remember semicolons between them. We'll have 2 semicolons total in the for loop. So for this problem, what's our first, so we want to see out even numbers. So what do we do first in this for loop? Yeah, so we have to initialize what even number is. So we say int even number equals 0. Note that with the for loop, we kind of say what the value is too. So that helps us remember to set a value. I remember with Wordle, sometimes people forgot to put num guesses equals 0 at the start of the code, and then they were confused why their while loop wasn't running. So with for loops, it kind of reminds you to actually set a value. So we set it equal to 0. Even number is less than or equal to 20. That's our condition. And then at the end, ooh, it should be even number. What's the mistake there? Yeah. I know for some of you that have done coding in other languages, the variable I is often used in loops. I would still encourage to choose good names. If it's just purely to count something, then maybe I is okay. But generally, I think it still helps to have descriptive variable names. That way when people see your code, they know what's going on. Okay, so now we'll have pass the paper to the other person, and they'll be writing the for loop with your help for the microwave countdown problem.
Times greater than 0. And then time equals time minus 1. And then you just see how you're like.
You got it. Like that. We don't do that.
Okay, cool. We'll bring it back. Okay. So what do we call this first block? Yeah, and we call that the initialization. So time is equal to 15. Cool. Bring that back. Okay. And then what do we call the second box?
Time is greater than 0.
Yep, and we call that the condition. So time is greater than 0. And then what's the last box? Yeah, so this is what we call the update. Yeah, I kind of, as you can see, just copied the code from the previous one and then update everything. Cool. Time is equal to time minus 1. Okay. One thing that I'll show, so people have kind of already been doing it, but I'll just fully formalize this. Let me create a new slide for this. Slide library. Okay, let's see what it's called actually. Plus equals operator name. Addition assignment, cool. Okay. So we'll call these like operation assignment operators. So right now we've been writing code that looks like this. We've said like counter is equal to counter plus 1. And it's kind of a lot that we have to type out. But I really wanted people to learn it this way so that you really knew like, okay, the right side runs first. We take the previous value of counter, we add 1, we store that in the new value for counter. Right? People are familiar with how that works? The other way you can write that is counter plus equals 1. Okay? So both of these are the same thing. And this is what we call the addition assignment operator. We could have done it even with like even number is equal to even number plus 2. How could we write that using the addition assignment operator? Yeah, so even number plus equals 2. Note the plus sign has to come before the equals in this case. So addition assignment operator. We can also do, like in our time example, we had time is equal to time minus 1. Can people guess how we can write that using this style? Yeah, time minus equals 1. And can anyone take a guess what this one would be called?
Subtraction assignment.
Yeah, so we need both, right? Because it's doing two things. It's subtracting and it's assigning back into time. So if you see this in your mind, you should be expanding it to this statement. So what it's saying is like taking the previous value of time and subtracting 1. Or this one's saying take the previous number of take the previous value of even number and add 2 to it. Yeah.
Does this also work with some of the other operators like multiplication, division, and whatnot?
Yeah. You can do times equals and can you do divide equals? I think you can. Let's double check it in the EdStem. Or we'll just do it. Okay, we'll try it in the EdStem. I think it's less common to do it with division and multiplication, but I'm pretty sure you can. Okay, so if we had like inf points equals 5, and we wanted to do points times equals 2. So okay, it just looks weird, but what do you think is going to happen here? What is going to be printed out? Yeah, I think it will be 10 as well. Let's see. 10, yeah. I think it's a little bit less clear what this is doing. Honestly, with multiplication, I would just do it like that, just to be super clear. I think with addition and subtraction, it's easier to see what's happening. Like if you just see like points plus equals like 3, I think it's easier to see like you're adding 3 to it, but personal preference. I guess we wanted to also check division. Division should also work as well. So if we did points divided equals 3, that should print out 2. Yeah, so it works. It works for all 4. All right. Any questions here? There isn't really a strong preference one way or the other. Like if you prefer to just write it out each time, like that's fine style. I just want to make you aware so that, especially because I think our textbook does it like with this style, I just want, if you see this elsewhere or you see someone else's code, that you know what's going on if you see this. But how you write your code is up to you. Yep. Any questions on operation assignment operators? Okay. And I'll just put a note here. Works for division and multiplication. Divide equals and multiplication times equals as well. Okay. Final problem. This one I'll have everyone try it by themselves. We're trying to print the letters in a word. We've done this example a lot with while loops, but we're going to try it with for loops. And in this case, we're going to assume that the length of the word will always be 4 letters long. So if you have paper, write it out by yourself. If you need paper, let me know. I can pass you a sheet. And I'll get a sheet. Write out by yourself what you think the answer is going to be here. And I'll collect these sheets. You don't have to write your name. I just want to see where we stand on this. Yeah.
Are we just printing bird or any?
You'll like use the word variable. If you want to try using an assignment operator.
Wait, so whatever it's supposed to be here.
So essentially, write out your for loop. So like what's going to go here, and then see out like we're trying to print each letter on a new line.
Oh.
Each letter in Word. Sorry. Yeah, print each letter in Word. Like using the word variable. So yeah. Right. Yeah. So not bird. We'll be using Word, but we'll assume Word is always 4 letters. especially double check the condition. Make sure, like, count on your fingers that it's actually going to run the number of times you want it to run. Joy, you good here? Alright, so try to just index right now doesn't have value, and then double check your condition as well. Got you good? Okay, so just, I think all the parts are correct. Just two things. So instead of like bird, like instead of the string literal, like we can use the word variable. That way it works for any word. And then just the order of the loop. So if you look at one of your previous examples, so I guess just kind of see like the order here. So it's like the variable initialization first, then the condition, then the update. So I think your like order is kind of switched a little bit. Yeah.
Yeah, I got this one a few days ago. It's because this is for the second year one. But yeah, it says second year right there. They're just sending those out and they know the classes off. Wait for a response to the first year one.
Like we do the
That's because we both did it for sophomores.
set the variable first, so you will have your index equals something. That'll just be a single equal sign.
Yeah, I got it.
Then you have your condition. So more times, put there, and then how you update it. Okay, so what did you put for your initialization?
What are they scheduled for? I have one already.
You set it equal to
4 with cruise.
And then if we wanted to run 4 times.
I remember that. I remember you told me about that. Yeah. How did you study? How did you prepare?
So we found out it equals 0.
I didn't prepare.
I did alright. Did you do the stuff that module or
So we had
something?
less than 3, makes it 0.
There's a module for this?
1.
Yeah, we got a module.
There's a module for this month. We have to sign up. We have to sign up for something. Or maybe I already did.
Interview prep.
Yeah.
Is it
I already did that.
And then
Yeah, I
word.
did a mock interview. I did too.
So right now it's just gonna print the entire word each time. What can we put after
If it's
word?
carrot,
Is
it's
carrot.
it's not.
It'll be like the square brackets and then you need
Yeah,
something.
it's
Sorry,
carrot.
Sandra, what was the question?
No, I said,
So, yeah, we're gonna see out like word and then something in the square brackets.
Yeah. Troy just told me.
Alright, we'll bring it back together. Okay. Okay. Close. I guess where do you get the 7 from? Okay. Yeah. And then also starting it at 0. Okay, cool. I think people are on the right track. Let's take a look. Okay. So really with for loops, it's just remembering what are the 3 things that go in here. Initialization, condition, update. What's our initialization going to be?
Index and index.
Yeah. So remember when we're going through a string, we start counting at 0. So the index is going to be equal to 0. What do we put for the condition?
Index is less than 4.
Yeah, you can say less than 4, or you can say less than or equal to 3. Both work. I saw some off by 1 errors. Again, just count it out on your fingers to see how many times. So in this case, index is 0, so it runs the first time. Index is 1, index is 2, index is 3. We've run 4 times. Now when index is 4, that's no longer less than or equal to 3. All right, how do we update?
It's gonna be index plus plus, index plus 1.
Okay.
Index equals index.
Yeah, so we can do index equals index plus 1. If we wanted to do it with the addition assignment operator, what can we do instead?
X equal 1.
Yeah. I know people are mentioning plus plus. We'll maybe cover that later. For now, we'll just stick with this. So you can do index plus equals 1. That's going to increase index by 1 each time. All right. And then finally, what goes in our while loop?
Word index bracket.
Yeah, so word, bracket, index. And again, what this is saying is, in Word, the first time when index is 0, it's saying take the 0th letter, print out the 0th letter in Word, which is V. Then index is 1, so print out the first position in Word, which is I. Then the second position in Word, which is R. Then the third position in Word, which is D. And then the nice thing with doing it like this is if we ever change this bird, our code will still work with the new word. Yeah.
Can you use any variable instead of index?
You can use any variable. Index is usually the standard if we are going through a string. And when we learn about arrays later, index also is generally the standard for that too. I think the nice thing with using index is when people see this, they know that you're starting your count at 0. So usually when we use the variable counter, sometimes like that usually has a connotation of starting at 1, whereas index is like very much a CS term, and it'll remind people that you're starting at 0. Yeah. All right. Any questions here? Sweet. Final topic I have today, variable scope. You're not going to encounter this error very often, but if you do, I want you to be familiar with why it's happening. So in our for loop, we create this variable int index equals 0. This is kind of the example that we just did. What happens if outside of this loop, we want to print out whatever the index is? You generally wouldn't do this, which is why the error doesn't happen that often. But why do people think this might be an error?
Is it because like the variable is like called like named and called in the while loop, so it can't be outside of the while loop?
So for loop, and yes, it's yeah. So we define this int index equals 0 inside, like essentially we're defining it just for this for loop. If we define it inside these parentheses, then we're saying we can only use the variable in this for loop block. And so later, once we come here and we try to use the index variable, this index variable is going to ignore everything in here. And it's going to see, okay, where above have we created an index variable? And we haven't. Yeah.
So the reason why we would use a while loop instead of a for loop is if we want to call the variable more than one time. Is that like the...
That's one way. We can still get this to work even with a for loop. Generally, the difference for when we'd use a for loop versus a while loop, for counting problems, when we know exactly how many times the loop is going to run, we're generally going to use a for loop. And for any other case, if we don't know how many times it will run, then we'll use a while loop. And so generally the way I'd break it down is validation, use a while loop, counting, use a for loop. Okay. To Freddie's point, if we wanted to use index later in our code for some reason, you would just have to define int index before your for loop starts. And then in here, you still have your variable assignment. So you can still assign it to something in here, but note that the variable definition ends up outside the loop. And so now we would be able to use index elsewhere in our code.
So are you saying like if you initialize a variable in a loop, you can't use it outside of that?
Yeah.
Okay.
So it really just depends where you define the variable. In this example, we define the variable outside, so we can use it anywhere in our code. In this previous example with the error, we defined the variable inside the loop. And so we couldn't use it elsewhere. John, you had a question? Okay, cool. Generally with like counting for loops, we're almost like, I would guess 90% of the cases, we're just gonna use the variable in the loop. So realistically, you're probably not gonna run into this error. But if you do, if for whatever case you have some code where you need to use the for loop variable outside of the for loop, the way you would fix it is just by defining the variable outside the loop. And then you still assign it a value in here.
The same thing for an if statement.
In an if statement, you can't, like, you don't even have the option to define a variable in the if statement. So we don't have that problem there. And in while loops, you won't have this problem either, because in while loops, you also can't define a variable in the while loop. So this is really just for for loops where this could potentially come. Okay. Any questions on variable scope or anything with for loops in general? Again, best way is to practice. So on Wednesday's lecture, we're going to practice using functions and for loops. We're going to put both concepts together. Just announcements. I posted on the EdStem, but in case you missed it, let me just pull it up. Okay. Lectures are still important and mandatory this week. Thank you for coming today. Make sure you come in on Wednesday and Friday as well, because we are covering important topics. To give you back some time for homecoming week, I'll cancel the Lab 8 assignment for this week, especially I think Trey and Dave were saying there's like a concert on Wednesday. We didn't want students to have to choose between lab and like participating in the festivities. So that'll be my compromise to you all, but please still come in for lectures. And then importantly, if you haven't finished Lab 7 yet, come in for today's lab. It's just the Wednesday and Friday lab that are canceled. But today's lab, if you haven't finished Lab 7, one of the most important labs of the semester, still make sure you come in and get it finished. That'll be at 5 p.m. My office hours this week will be very limited because I have to cover Dr. Watkins' classes. So yeah, if you want to come in for office hours, talk to me after class and we can figure out a time where you can come in. Yep. All right, and then homework 6 due tonight. Lab 7, if you haven't finished it, come into lab today. Yep. All right, that's all I have. Thanks, everyone.